Vignette is the first where we're going to actually start looking specifically at how to use R. And what we're going to do here is look at a very important part of most programming languages. It's what are called packages or libraries and so on. So first going to detail a little bit what we mean by packages, and then I'm going to show you how to do a variety of things with packages. And before I begin, I will point out, and this is important, that if you are in one of my courses in which I use R, and in particular math of data science, then there is a section in these slides called a friendly method, essentially, that I'm going to ask you to take a look at, and I will point out that if you don't use the method that I'm explaining there to load packages, then you might lose a few points in your assignments, and it will become clear later. I will explain where this is coming from. So what's a package? And it's package, libraries, but both words are used actually in the functions that deal with packages in R. They're typically called libraries, but both terms are used. So the idea, and as I said, this is common to most programming languages, these packages or libraries, they extend the programming language in question, so in this case R, by providing functions or data that are useful in some contexts, but that are not useful in the general use case of the program. So the idea is that you're going to put in the main library, let's say, just what is needed for everyday use. And then everything a bit more evolved than this will come through specific libraries or packages. So as I've indicated before for other things, if you are looking for packages, then the first place to look is CRAN, so a comprehensive R archive network. And so here what I'm doing is I'm showing you the result of this command, and again, I haven't really introduced R so far, and I'll point out that this command, this is Quarto, these slides are in Quarto, and this command was run today when I compiled, when I generated the slides. So what I'm doing here is I'm looking at available packages. I'm counting the number of rows in the result of that function, and I'm making what do you call that? I'm making a string that contains this number and that statement packages on CRAN on whatever the date is when I run it. And so the result, as you can see, is quite impressive. There are over 20,000 packages on CRAN, which means there's an enormous variety of ways for you to expand your base R, because there's about 20,000 packages just right here. I will point out that, of course, as you can expect, packages vary greatly in quality. And in the amount of things they do. There are packages that provide an entire expansion on a given topic. It will do a lot of things. I've already pointed out dsolve in our vignettes. Dsolve is a package to solve differential equations numerically. And this is something we use a lot in modeling, and dsolve has a lot of functionalities, but there are packages that provide, for example, just one data set. They all have a use. As I said, they vary in quality, so you have to sometimes shop around, see if you can find a package that does something better than another package. But altogether, there is a lot that is available on the web. But I'll point out that CRAN is not the only place where packages can be found. So for example, there's quite a lot of packages that can be found on GitHub. I'll point out later, so sometimes packages also get removed from CRAN, but they're still accessible. Okay. So if you're dealing with something that is not on CRAN, you'll see it's a slightly different from the general way of installing things. So how does one install a package? So from CRAN, the typical method is using the command install.packages and the name of a package between quotation marks or single quotation marks. They don't have to be double. So for example, dsolve, the package I was talking about for differential equations, if I wanted to install it, this is how I would do it. But again, I recommend that you take a look at that friendly method that I mentioned, that is coming up later. You can also use RStudio, so let me show you this. So this is an RStudio window, and you can see that these are the remnants from a query I made some time back. If I want to install a package, so let me, then I can go to that top, oh, I'm not seeing that's interesting. So if you click here, so for some reason this is not showing, there is a menu that comes out which bears the, if I click here, this one shows, it brings out a small window, and you see that that window has, it's asking where you're trying to install the package from, so CRAN, and for example, I could start typing dsolve, and you'd see that this installs dsolve in my install. Just in passing, this is a Windows machine, and I have some remarks about using a non-Windows machine later, or non-Mac, so using Linux. But so here I've installed the package dsolve by just clicking Tools, Install Packages, which, as I said, for some reason you're not seeing that drop-down menu, but then typing the name, and you can put several packages at the same time by just separating them by commas or spaces, and it will search for the package name in the list of packages. Okay, so this is what I was saying about RStudio. Where am I? I am here. Okay. You can also install packages from GitHub, and just to explain a little bit, to include a package in CRAN, there are a number of steps that have to be taken. They're not complicated. It's easy to put a package on CRAN, but it happens quite often that people, when they develop, before they think that a package is actually ready for global diffusion, they will have it on GitHub. Or another option is, if you're looking at a good, well-known package, it often happens that the testing version of the bleeding edge version of your package is on GitHub, and the stable version is on CRAN. To install something that's on GitHub, you'll probably use some what's called DevTools or remotes. These are packages that deal with installing from other sources, and DevTools is my favorite of the two, but they both work. There's also even a package that's called GitHub install that you can install from GitHub and allows you to very easily install packages from other packages from GitHub later. So for example, I'm a big fan of XKCD, which if you don't know, you should look up. I should add a link to the website. I will in the slides. I'll edit the slides and you'll have a link here to XKCD. But there are actually, there's not a single one, there are packages that allow you to create graphs that have XKCD look and feel. And if I wanted to use to install such a package, I could first load the library GitHub install and then say GitHub install XKCD, and it's going to propose to me two packages about XKCD that live on GitHub. And so for example, I would say, okay, let me take package 2 and it would install, and etc. One interesting thing, as I said, putting a package on CRAN is not complicated, but they have a very strict policy in terms of a variety of things. For instance, if you're a package developer, you have to update the package from time to time. You have to reply to automatic emails, etc. So it happens quite often, or not quite often, but it happens that a package would be removed from CRAN for a variety of reasons. And so here, this is, I'm taking the example of a package that I use a lot, but it's very convenient. It's called HTML tab. And you can see that here it says package HTML tab was removed from a CRAN repository. There's a former version available here. It's archived for policy. It doesn't say what policy it violated. I don't know if it's because the author didn't reply to emails or if there's something more formal or whatever. It doesn't say why, but you can see that it has been archived. So if you try to install it using install packages or the GitHub, RStudio version, it's not going to work. So I'll point out that in this case, it actually turns out that there are versions on GitHub, so you could use what I was explaining before, but just to illustrate, this is what would happen if you wanted to do it directly. So you would go there, and then you'd look for the versions before, and you can see that there's a bunch of versions here. You can download this file. Of course, you'd pick the latest one, so probably this one. You can download this file and install it using commands. So let me show you. This is very simple to do. Well, I'd have downloaded it and put it in the directory downloads, and I just say download. Okay, this is the name of the file, and I say install packages, but here I have to say that it's a source file. Okay, or you can even point directly to the link. So this was the link this was the link that we saw on the web page. Okay, so I just enter that link as a URL. I mean, it's not a URL, it's a character chain, and then I just say install packages from that URL, and it's a source file. In both cases, I will end up with a package on as part of my R installation. Okay, so once a package is installed, you need to load it to be able to use it. So it's not just the installation, you also need to indicate that you want to load it to memory. So to do this, it's quite simple. You use the command library. And whereas to install a package, you need to use quotation marks. When you're loading a library, you don't need to use quotation marks. You can just use the name without quotes. And you can also use RStudio to load a package. So let me show you this briefly. So here I have my RStudio session. And what you can see is that here I'm going to magnify the right-hand side. Along the things you have here are the list of packages, And if I want to load a package in memory in our studio, I just select that package, click on it, and it will load. Here, apparently I took something that wasn't really clever, and you can also unload equally easily with our studio. So here, for example, let me load the solve. You see it's loaded, and the command to unload. It's rare that you have to do it, but if you do need, this is what has appeared here. It's detach. So you see here, if I detach the package, it is not in memory anymore. As I said, this is going to be extremely rare that you have to do something like this. This is typically not something we have to do. So going back to the slides, I need to get my slides back up. One remark, it is often interesting to load several packages at once, but if you want to do that, you're going to have to use a command a bit like I have written here. So here I'm indicating what packages I need. So ggplot2 is a package that does plotting. We will see examples here and there of using it. Deployer is a package which is used for manipulating data. We will also talk about that package later. The only thing that you have to bear in mind if you want to use a loop, so here this is a loop, vignette on loops, a bit later that you can look at, the one on control, flow control in R. But here for the moment, just know that what I'm doing is I'm making this this vector with the name of packages I want to load, and then I'm saying loop on those two vectors here. So for a value of p in those two values, then instead of just doing library as I did before, I need to do library of that variable and use this command, this option of the library command, character only equals true, because otherwise this will not work. So if you're trying to load multiple libraries in a loop and it doesn't work, it is because you've probably forgotten that character equals true statement. So this be friendly to others little explanation is in particular for students in math of data science, but it's true for everybody else, and I want to spend a little time discussing this. So the idea here is that if you are, and you will often be distributing your code to others, collaborators, profs, whatever, then you need to think about those people. So if you are using an unusual library, it's possible that the person that is going to run your code does not have that library installed. Okay, as I pointed out, there are 20 or so thousand libraries in CRAN, so it is very common that you'll end up using a library that the person that you are sending your code to is not aware of. So if that's the case, it is really nice for them if you sort of do the legwork and you show them how to install the library, and in particular, so you load the library. And load the library, yes, but also install it, because okay, it takes some steps. If, for example, so going back to this being used as a course, when students in Math 2740 submit their code, there's 120 of them. They all submit a piece of code. If each one of them uses a different library, and every single time we have to go install packages, etc., it's complicated. So it is very nice of you to do that. But at the same time, you have to bear in mind that second point that I'm making. It's possible that the person has the library installed. And if that person is someone like me, or for instance, someone working on a Jupyter notebook installation on Unix, then every time you install a package, so if the example I gave earlier where I was installing a package under RStudio in Windows is very different from what life is for us in the Unix world, because in Windows you get your package, it is just copied locally, there's a few things that are done, but it runs out of the box in general. In Unix, every single package that you install, I mean, that is not entirely true, but most packages that you install are going to be compiled to be installed. And that means it can take a lot of time to install a package. If every single person who sends us some code is requiring us to install the library, becomes very painful after a while. And so that means we have to go in the code to check that the install packages option is removed. So that makes it inconvenient. So there is a very easy way to be nice to the people that you're doing this for. And that is to do the following. So instead of installing a package, well, install the package and load it, what you can do is, if I'm looking at some package that I've called package name here, if I want the person I'm sending the code to be able to do things easily, I would say if not require package name. So what required does is it does exactly the same as library. It tries to load the package, but if it fails to load the package because the package is not installed on the person's computer, then it just throws an error message. So if the package is not installed, it throws a false message. So here, by saying if not require package name, this means if the loading of package name fails, then this will return a true value. Okay. Then if that's the case, well, then install that package name and then load it. So if you do that, what happens is the person that is running your code, when they run this little piece of code, they either load the package in memory if they have it already, or they install the package and then they load it to memory. Okay, so this is a nicer way to communicate your code to others, because it actually gives them the option of first getting the installation done if it's needed, but not getting it done again if it is not needed. And if you're in math of data science and you don't do that, at some point you'll start losing points. Okay. So, for example, if you wanted to do it with two libraries, I take the same example I had before. Suppose I want my user to be able to use ggplot2 and deployer, then all I need to do is let me loop on these packages that are required, that I've put in this vector. If it doesn't work, and here require also needs the same option, character only equals true, as we saw before in the library. So if that fails, install that package, and if not, and once you've installed it, load it, or otherwise, this means this has worked the first time around, and the library was always already there, and therefore there is no need to install it. Oops. Now, updating packages. First of all, RStudio again allows you to do this. So there is an option here, and I'm guessing this is not going to appear again. You can go to Tools here, and in there's going to be a check package updates, and you see here, oh my gosh, okay, it's returned a long list of packages that I can update. I can choose to update a single one of them, or I can select all of them and update them. I'm not going to do that right now, but this is possible. You can also use that button here that you see, update. If I do this, I get to the same point when I'm on the packages tab here. Okay, so I can go here and it will throw the same information. If I want, I will select all of them and go forward with the installation, with the update of the packages. I probably should say one thing about package versions. So sometimes, and this is something I haven't made a vignette about, but maybe I will. Sometimes it's dangerous to update a package version, and there is actually a whole aspect of R that concerns distribution of code with a certain prescribed package version, because sometimes when a package changes version, some of the behavior changes, and there is a way to ensure that your code is distributed, for example, to collaborators using a prescribed set of package versions. I won't talk about it here, but I might do a vignette about it later. This is important in terms of reproducibility. So it is not always the best idea to update packages. It is usually a good idea, but if you are doing critical stuff that really depends on a given version of a package, it might be worth thinking of checking that the update is not going to break things. You can also update things from the command line. In this case, the command is update packages. And so here I've put what would be a typical command for this. So the options here are ask equals false. So this means that when you're running the updates, it is not going to ask you for confirmation if it needs confirmation. So it might say, okay, do you really want to do this? Well, if you put ask equals false, there's no confirmation needed, it just proceeds. Check build equals true is an important option in some sense. It just checks that the version of R with which the package was built is corresponding to the one you have on your machine. This is particularly important, as I was saying, for us in the Linux and Unix world. Packages are compiled when they are installed, and so if I have a package that's compiled with an earlier version of R, there might be differences, and so I might want to run check build equals true. And finally, there is one important thing if you're in the Unix world again. I mean, it works in Windows and Mac as well, I suppose, but it's not as critical because you don't compile all the packages. But in the Unix world, using a command like this, an option like this, is very useful. It just says when you're doing compilation of packages, especially during these updates, you can use a certain number of parallel processes to do so. So for example, here this is saying you can compile 6 packages essentially at the same time, or you can compile 6 different files in the same package at the same time instead of proceeding just sequentially. So this is really useful if you have a large machine. So I'm recording this on a machine with 128 threads, for example. If I have a lot of packages to install, I can just put a large number of CPUs, and this will make the process all the more fast. One essentially last remark about packages is that every time there's a new major version of R, so the current one is 4.3. So major version is first digit and second digit. Okay, it does not to the third digit. But so currently R is in 4.3, for example. And what's going to happen is all the packages are going to be installed in something that looks essentially like this. It might differ if you're in the Windows or in the Mac, but it essentially goes under whatever you have called your home directory for R. And then it's going to make a directory R and then a subdirectory that is going to be related to the architecture you're using. So you can see here I'm on a Linux box, and then a subdirectory with the major R version. When that version changes, essentially every year, roughly, then all the packages that were installed under 4.2, for instance, cease to be used. And so there's, interestingly, no general mechanism planned for doing an upgrade. So one thing you can do, for example, if you're in the Windows, what I have done in the past, and that works, is simply take all the packages in the previous version, so 4.2. There will be a lot of directories in this folder, and just copy them to 4.3 and try to see if it will update. Another thing you can do is to try to export the list of packages that you have installed. And so here, for example, I'm showing you how to do this. Suppose my previous version is 4.2, therefore all my packages are installed in this directory here. And what I want to do is, for example, get the list of installed packages, but where I'm going to say that I'm going to check what packages are installed in this particular directory, not like if at the moment when R went from 4.2 to 4.3, the main directory became 4.3, but here I'm asking it to look at 4.2. And I'm making a list of installed packages, and then I could use the same loop as I've used before to install each of these packages manually. So this is something you'll spend some time on from time to time. Every year, essentially, when your R version updates, you end up doing these manipulation with packages, and this is one way to do it, for instance.